So Isaiah, walk me through the SEG. You've built several of these.
So this is version 3 of, I'm on the version 6 already. Version 3, it's pretty simple. You just have laminated steel electromagnets and MOSFETs for the pulsars. It's triggered by LEDs and a LED, basically a sensor. So each one gets a sensor of its own, so it keeps it independent. And then I just have the 12 rollers and the inner stator. The elements are a little different on this. This is just experimental, but this is the inner core is nickel 200, then Teflon, the magnetic layer, and copper. The same on the rollers. I have a real basic setup. I have temperature sensors, then a temperature gauge for the center, and then the coils and MOSFETs have temperature gauges on them. I'm just using a Milwaukee battery. It's quick and rechargeable. This one's a 3 amp. Always over here, there's probably something screwy with one of these, but once it, there we go. Once it overcomes that, it really builds up the speed. It's probably doing about 150, 180 RPM. They all keep their distance equally. As long as there's enough power on these electromagnets, they flow quite well. And you can dial the speed up or down, so 50%, whatever.
And one of the things that I remember you saying was that as the speed reaches a certain point, they get quiet, right?
They get quiet, yeah, and I can show that on this one. This one doesn't really do that all that well, but that one, it definitely does. This one just doesn't have the speed as the carousel does. There we go. It hits a moment of this, stops the rattling and it really takes off. But this has no special pattern. These are just industry standard magnets and so are the rollers. The centers are unmagnetized. It's just the rings on the rollers and the stator is magnetized. These weights are pretty close to being the same, within a gram accuracy. The lights are mirror for basically whenever the electromagnet is pulsed, the white turns on, and whenever it's off, the blue is triggered.
Okay. And the camera's not really picking, it's not showing, but you can see them pulsing with the eye.
Yeah, it's pretty fast.
How long did this take to build?
Three, 4 months. Quite a lot of work. And this was just one of the very first versions. We used laminated steel instead of just solid iron, and that greatly enhanced the strength of the electromagnet. These strands, and there's eight wires per strand per wrap. Instead of just using one wire and repeatedly wrapping it, we've divided the whole entire segment into 8, so that it's a much stronger field instead of just one wire continually wrapped. It lowers the resistance, definitely. And the MOSFETs are getting hot. That's the only thing on this version. The MOSFETs would heat up pretty fast on some of them. So that's full blast. I believe it just needs more voltage, which I would do is just add another battery to it. That one also looks like it does faster speeds. I think it's just because these are much larger and they just take more power to run it. But it is a much more smoother system.
You see the lights going off this time.
It's nice you can see they follow the rollers. Yeah, this one's all balanced. That's these, what was it? Not inductors. What was it? Inductors? Each inductor is specifically wound to match this so that each one is balanced. So everyone has a different value. That way they all have the same exact inductance value to each electromagnet.
Yeah, and then these are single roller systems. And in fact, in this case, you've only got, I think, 2 rollers on it, right?
Correct.
Yeah. So it's just a demo. Nobody should get too excited yet. But
Yeah, it's just a demo, yeah.
now, with a single roller system like this, are you able to demonstrate any of Surl's predicted effects?
The one thing I can show, and I have to show on the carriage system, is it does get quiet at a certain RPM. It starts, you'll hear it, the noise drops down.
Okay. And then you mentioned a temperature change too.
So that was on my very first unit, which was this one back in 2008. The very, very, very first one. No matter which side I would flip it up and down, which I thought, oh, if it's sitting on the surface, it'll change. But that, even though I'd flip it upside down and back and forth, one side would be warmer than the bottom, or the other. And this was the very, very, very first version. These were neodymium magnets. These were normal, and same with the rollers. So that one I didn't notice, no matter which side it went, it always had a temperature differential. But so far with these units, I haven't felt any kind of cooling yet. But these, like with this one, it's definitely not even doing 200 RPM.
Yeah.
As with the carousel, can go up to, I can get these up to 598 RPM max so far, which is above what we're looking for.
Now, are you planning on building the additional ring systems?
Yes. Yep.
So that's on the list. But then those are more complex, right? And part of that's because you have to be precise on the inside and the outside.
Yeah. Yeah, they're bigger, way more expensive, and it gets more trickier because they're much larger. The rollers will stay the same. The rollers manufacturing process is all the same. It's when you get bigger, and I have those measurements. I figure after 10 years of trying to solve it, in 10 minutes I solved it. It all came to me at once, how to put the measurements. So I spent about a day and a half writing them all down. I got the measurements for ring 2 and ring 3.
Yeah, so have you been able to validate, I mean, like a lot of this is based on Searl's law of the squares, right?
So law of squares I know very little about, except that I'm following it. And like for instance, the rollers, he stated that each weight on the rollers must have a certain weight. Like the neodymium's 13 ounces, the Teflon 4 ounces, the magnetic layer exactly 10 ounces, and the copper grams each. And when they're combined equals 34 grams total. And it's talking like within 1/10 of a gram accuracy. Very, very accurate, but doable. You just have to put the time in to get each layer right. And I've done that before. Now these are not, these were just because the copper was readily available. But my next version of like these rollers, these are within about 1/10 of a gram accuracy of 10 grams. And these can do almost about 500 RPM.
Ah, okay.
So these are ones I'm going to be having a custom-made ring jacket, the layers to be made on them. The Teflon parts I already have made, and the neodymium I'm making for these. But these are the 10 gram each magnetic layers, and these are N55 magnets.
Okay, okay.
So to answer your question,
So the single roller is here, and the multiple roller the multiple layer is coming. Basically, that's
yes, and it's just like my main goal with this is like I really want to max this out to get up to 500 RPM. This can't do it. That can. And
okay.
that can go way beyond 500 RPM. But 500 to 600 RPM was our goal, and we way surpassed it.
Okay.
So to answer your question with law of squares, I just printed these out real quick. So he arranged these numbers so they all equal 34. So there's a randomness in these squares, 1 through 16. And here's just standard. If you just 1, 2, 3, 4, 5, 6, 7, 8, 16, everything is all random. But surprisingly, these numbers are all the same as these numbers. And these are the numbers I'm using. In his dream, it said start with square 4. And I don't know why he didn't go this direction or that, but he chose this direction. So here you have like the Teflon layer, the copper layer, the magnetic layer, and the neodymium. And that's what he bases it off of. What Jason Ravelli says is when you stick to these rules with the rollers, it promotes electron flow to the optimum level.
Okay, and that's kind of he's described this as a gate,
Yeah.
right? So, and let me zoom in there. So he's described this as a gate, and so you do have electron flow, presumably. So this is an insulator, this is plastic, and then, let me see, magnet, and then copper jacket, and then the inside here, that's magnet as well, right?
That's actually unmagnetized.
Oh, okay.
So this one was just experimental only. This is only about 34% neodymium. It could be magnetized into a magnet. It actually was a magnet. They just never magnetized it for me, and they didn't coat it. They put no coating on it. I want it raw. So there has been a little bit of oxidization, which is good because I actually, if it didn't oxidize, I would know there's probably nothing of value. But a lot of it is iron, and there's a little bit of boron and sulfur and the components they use to make a magnet. The versions I'm working on will be 99% pure neodymium with a resin binder. That's what I'm working towards, and it's what this little guy here is. I proved it could be done. The only thing, unfortunately, is they're not compressed like normal neodymium would be, but that is pure neodymium and a little bit of resin, and it has not oxidized in the slightest. This is about a year old.
Oh.
So this is what I'll be going for the insides, and also making a large version like this.
So as you continue to work on this, do you feel more confident about all of Searl's claims?
From everything I've heard, except for flying, I have no reason to doubt it yet. And as time has gone by, both me and Jared have seen that the things he's saying, like the magnetic locking, the rollers wouldn't come off. And one of the things I know, like with his rollers and his magnetization process, like a standard magnetization process, it's just one flat line, but his would have thousands of little pinpricks of magnetization. What I've seen with the CMR magnets is they can print fields on their magnets, is the more smaller the field you can put onto a normal magnet, the stronger it becomes. I even have a picture up there. A 2-inch disc, they can put 200 little pixels. That makes it 600 times stronger on that one disc compared to just being normal. What Surl said is that no matter what speed he got it up to, that his rollers would not come off. I tend to believe that because his system had like thousands of little pinpricks of magnetism instead of just one field. So that's one thing I suspect. The other thing that I've sent to Jared and have seen is that magnetic demo. It's a magic trick right now, but it used 2 fields and it locks in a third magnet. And no matter what direction you go, except for up and down, it holds it without physically touching. It's something that Surl talked about in his rollers, 50, 60, 70 years ago. The cooling effect I've seen with, was it 3? I know of 2 people that had experienced a cooling effect. One was Roshan and Godin. Their machine produced a cooling effect. The other was Mr. Delphin in Russia a few years back. He had it, his machine, vaguely similar to this, but his neodymium in about a minute and a half went down to negative 17.5 C. Very quickly, it cooled down in the center, then propagated down outside the copper, then started interacting with the rollers. I mean, it got down really, really cold. No one else except for Surl himself had done that. And to me, when I saw that, I just about keeled over. So that was like more verification. What Surl said all those decades ago is actually true.
So you mentioned Delphin a minute ago. That's another, I've never heard of that one. So the ones that I'm aware of, the replications I'm aware of are, you had Godin and Roshan. That one is pretty famous. And if I remember correctly, they described it running cold, and they said they had self-spin.
That's what I heard, yeah.
And then you had the Morningstar Energy Box. That was Paul Murad and John Brandenburg. And he claimed they had transient weight reduction.
Yeah, I heard that too.
And so there were those two. You mentioned another one called Delphin, and then Fernando Morris, I believe, built a bunch of single rotor systems. Right?
And those have unique, from what I heard from Russell, those have unique magnetizing on them. I thought forever they were just normal stock magnets, but they weren't. They used special magnetizing on the rollers. And that's how they are. They're quite different from these because he was able to get 200 RPM with 6-volt input and 1.6 amps for the entire system for all 12 rollers, and they all did 200 RPM. I have that sheet with the blueprints and everything he sent me years ago, and that's how I built these. I based these models off it, and I've altered it a million times, the circuits. But yeah, it shows all those stats. It's quite remarkable. He could spin those up at such a tiny little voltage and amperage.
Yeah.
There is one more replica because it's somebody I worked with years ago. He helped buy some of these magnets that I'm using today. I haven't heard from him since 2018. And I won't give it the last name, but his first name was James.
Okay.
He was from the UK. And he worked with a gentleman, you can find his work on the internet. His last name is Kumar. So James worked with this Indian guy, Kumar. And Kumar developed a magnetizing process and succeeded in building 3 working SEGs. And soon after at work, Kumar got radiation sickness because he worked with alternators and radiation equipment. And he's still sick right now. One of the units that they had up and running, they sent to some engineering teams in China, and one of those engineers contacted me trying to get a hold of James. But they got the unit, it ran all by itself, just like Surl's.
Self-spin.
Self-spin, everything, and they took it apart, put it back together, and nothing worked.
Okay, so something changed.
They broke it. So that is the other story. The guy has not sent me any pictures. It's only been word of mouth. I don't know if James is alive or dead or alive right now.
One of the things that I've heard is that, again, like as the magnetization is imprinted as kind of a signal on those rollers,
It is.
if you take those apart, even if it's not like quote unquote broken, right? Like when you put it back together, if they're not aligned correctly, maybe one of them is flipped or something, they're not even aware of that. Maybe that would cause the issue.
It has to be perfect alignment.
Yeah. So in theory, you'd want to build this and leave it together.
Correct.
Yeah.
Once assembled, it's like glass. If you try to take glass apart, it's shattered. It's broken.
Yeah. And this is a complex system, and the magnetic pieces, now as you mentioned, as the magnetic pieces spin, they maintain their own distance and separation too, right?
They do, yeah.
And one of the things that I'd read Searl talk about was supposedly the rollers maintain a minute separation from the disc also. They will actually come out from it just a little bit.
Yep. My next version 7, will be exemplifying that effect.
Ah, okay. Okay.
I haven't said much at all because this is all I've built it in my mind, and that's as far as it's gone. But it's something I've seen only on my power tools, is when you spin something that is, basically you spin a magnet and have a bolt on the bottom. If the bolt starts circling, it'll fling it off. But if the bolt starts spinning, and this is spinning really fast, and the bolt sits down here, you could spin that drill at full RPM and it won't fly off, even though they're both rotating extremely fast, because it's all magnetically held together.
Yeah.
So that's a principle I'm going to be building the next version off of.
That's been one of my takeaways from the Searl effect is when people first see this device, the first thing they see are wheels within wheels,
Yep.
right? And that's like at a glance. But then when you get into it, it's been described. In fact, I think Wikipedia describes it as a form of linear motor, or at least inspired by linear motor, right? And that's definitely part of it. And that would also explain like the magnetic imprinting on the rollers and all of that. It is also a magnetic gearing system.
Yeah, I've heard that too.
Yeah.
The one thing I haven't seen anything of, and they probably have it, like Jason Verbelli and Fernando Morris. I think one of the questions was if Fernando's still alive. He's definitely still alive. He's doing really well.
Oh, good.
Yeah, he's definitely still alive. So that is one of the things I haven't seen, except for just pictorial diagrams, like that one there, is the gearing system, what that looks magnetically. I have an idea in my head, but and then representations, but nothing magnetically how that actually looks.
The SEG has a tremendous cultural relevance. That's one of the things that intrigues me about it. It captivates people, it draws them in, it gets them excited, but it also has this history. And at least for me, I think when people think about anti-gravity, they build it into a couple, like T.T. Brown is one aspect of that. Surl is definitely the other one. It has rotation, it has spin, it has running cold, it has all of these like archetypes of what you would think of as like an over-unity anti-gravity device, right?
Correct. So. Yeah. The only thing, like with Surl, is there's, aside from mine, because mine has input. You're putting this into it. With his original ones, there was no input, except, I have to say, except to get it started. But once he got it to a certain rotation, it would just take off by itself, and then it would just take energy right out of the environment. Kind of like Roshan and Godin's would do, is it would start drawing and it would cool down.
Yeah.
And they had the self-spin after a certain RPM, it would just do self-spin and weight loss and all that good stuff. But with John's, I think his later versions, as he kept getting it better and better, he could merely, because he mentioned he could merely just push the roller and it would take off all by itself. It was that finely tuned.
Well, one of the big questions, and this would go to, one of the big skeptical criticisms is, why is it so hard and expensive to build these today if he was able to build them back in the, 50s, 60s? Mm-hmm.
To that I answer, because I've been on this 15 years. Knowing what I know and all the mistakes I've made, I don't see anybody to my level. I don't have any competition out there, aside from Searl Magnetics developing it. And although I know John did a lot of trial and error, but he also worked with a company that had tons of money to play around with.
Okay.
It'd almost be like if I was working with Boeing or Rolls-Royce and had favors with the bosses and the managers, and I could just play in my off time and use their resources and the things and have the equipment. I have access and availability and favor to hardware, and I could just play. If it's just me doing this and needing all that, millions of dollars of equipment, good luck. But he had access. He was in the right time and the right spot and the right place to do all that.
He had that dream to work from.
Yeah,
also.
the dreams to work off. Yeah.
And this goes back to the origin of his story, which was he had these dreams that gave him guidance. And you were describing the law of the squares earlier, and so there's a lot that goes into this that comes out of his vision of how this thing should be built.
And even, because I've experienced this so many countless times, even the neodymium, which is the critical part of the machine, he got the neodymium, he saw in the dream as the center element. The neodymium he got from the glass factory, which was right next door to the electrical winding place. It was right there, and he went over and just got handfuls of the stuff in bags. But they used it for glass, and it was right there in plenty and cheap. So it was all these things brought together for him to do it. But to answer your question, I think it's up to the individual, and not a lot of individuals have wanted to do this, nor have they had the resources and the money to do it. And especially the magnetizing, it's kind of the heart of the machine. It's tricky, and you can't just go buy something like that. You have to figure it out and work the bugs out. I mean, AC and DC magnetizing combined at 1 megawatt levels. I'm sorry, but there's no equipment out there on the planet that does that right now. You'd have to go create it from scratch. That's tough.
One of the things that amazes me about your work is that you have really drilled down into, this is what John Searl described, and I'm going to follow his model.
Yeah. It's one of the things I appreciate their input, and I see this on YouTube a lot, is people will be like, oh, why don't you try this? Why don't you try that? I'm like, those are good ideas. Really be great if you made a computer model and you could just type in things and change the vectors and all the points on the computer model and see what happens. Going and doing that, you're talking time, money, resources, and just to just get to where this is has taken me years and years, and just try something vastly different, like all these, aluminum here, and change this and change the magnetic field. It's like, that's great in thought, but going and doing it, that's hard.
Yeah.
Time, time, materials, money, all those things I don't have in plenty.
So when you expand this, how long do you think that project will be? I mean,
Years.
years.
Yeah. The next version coming, so this is my pride and joy for now, because it has, something I've never done before is this level of strength of magnetic, but also putting the program onto it. Each segment has a written program onto it, or written the drilled out segments I have corresponding to a pattern. I've never done anything like this before. I never have had results where I can get the magnetic segments up to almost 600 RPM. Never been done, except for Surl himself I'm aware of. The next upcoming version, which will be the rollers with all the exact correct weights. Each layer will be exactly dead on, and all this will be following the roller. So it'll probably be a 1/4 inch smaller.
Okay.
But that's the one I'm gonna, will be the version 7, and then I'm gonna do a second ring to follow with the adjacent rollers. So it's years.
And then the second ring, according to Searl, the second ring is actually producing more energy than the input.
Yeah.
And the third ring is the one that flies. That's the IGV, right?
That's the one, yeah. And speaking of the flying thing, so there was a gentleman I talked with about, I think at the beginning of this year, he worked with Surl for about 6 years. His name is Matthias Beige, and I think he's in UK right now. So we had about a 2.5 hour talk. He wanted to track down to find eyewitnesses who actually saw the flying ships, and he found 2 of them.
Okay.
So 2 eyewitnesses, not just somebody who saw on TV, but 2 physical eyewitnesses. One was a child and went out with their dad to the field where Surl would fly his ship. And they came out on a Sunday morning, and Surl was out there for about 2.5 hours, 3 hours, just adjusting the frequency. And when he got it right, it just took off. But the person remembers seeing it and being there with his dad and seeing it fly into the sky and never come back.
Okay, so there we go. So we do have some eyewitness testimony.
2 of them. They're still alive, apparently. And he found another person who was with Surl, and I think it was his brother, Peter, and he saw it fly too.
Okay.
So it's 2 people, 2 independent eyewitnesses.
Yeah, and I do remember in the Midlands area, Searl did get a fair amount of press at the time. There's lots of photographers and lots of interest and stuff like that.
Yep.
Now, going back to what you'd said about new interest and new people coming into this, in today's environment, we're more open, and I think that benefits everyone. So
I would love it if somebody else wants to take this on and do it. I mean, I honestly would be willing to part with this unit just so they can experiment with it. I'd be more than happy. It's like somebody could actually follow and do something with it, because I'm just moving on to this, and then version 7 will come along. But so far, I don't have any takers. I mean, I haven't seen anybody step up to the plate. It's very expensive, and it takes a lot of ingenuity. And I mean, I learned all this from scratch, pretty much. I didn't have any formal training.
yeah. Now, are you able to repurpose any of the parts from the ones that you build for new ones, or is it too difficult because of the diameters and sizes? Like roller sizes, you know what I mean?
Testing, like the rollers, these, I mean, it's on this unit. So that was version 2, 3. Version 3, I basically just left it to be, because the stator is fixed. It's all put together. I'm never taking it apart. So it's a good show and tell. Like this will be here indefinitely. I'm never taking it apart. So it's a good show and tell, and it'll probably just become just like version 3.
Well, and I don't think I have the camera rolling. These are heavy as heck.
Oh, yeah. They're very heavy.
What do you think that roller, just the roller part, what do you think that weighs?
Well, I measured these. These are about 3/4 of a pound each.
Okay, and that adds up.
Yeah, so you have 12 of them going around. It's quite a bit of weight, and you don't want to smack your hand when they're going.
Yes, I've heard that. Paul Murad had said that too. He'd said you have to keep in mind that they're magnetized and they're heavy and they're finger pinchers.
Oh yeah. Yeah, I've smashed my fingers a few times with these real high power magnets. When I put this together, I built a whole mechanical device to insert them with these huge control arms to push them together. And I had to have my roommate do the final. The final one was a pain. I knew it was going to be, but I actually put it in the freezer to get that 1/2 of a millimeter than I needed. I put it in the freezer and then put it in the last slot, and it went down, and when it warmed up, it's tight.
Perfect. Yeah. Yeah. Absolutely amazing device. Well, Isaiah, I think that was everything I had. I mean, if you have more you want to talk about, go for it. Yeah. Again.
So I'll give a highlight for version 7. Version 7, my goal is that there's no electromagnets, except for inductors only, no electromagnets, and no carousel. Basically, you'll just have the beautiful stator, the rollers on a flat plate, and they look to go by themselves.
So this would be the pure Surl vision then.
Well, there will be something operating to start it to get up to the certain RPM, because I'm going for appearance and functionality too. I just don't want all functionality and not looking pretty too. I want both. So I'm going to, because that's the whole goal with these, get it up to a certain RPM, which I think is about 500 to 600 RPM. Somewhere in there, that RPM, from what I've heard, is where the interesting stuff starts to happen. The cooling, the weight loss, the self-rotation, all within that RPM range. So that is my goal. For this, I tried to get 500 RPM, doesn't work. The carousel easily does it.
Okay.
But I want a system that just looks like nothing is running it, but it's running. So that's version 7 I'm working on right now, to where everything to run it will be underneath it, spinning it up at the RPM. So to just be beautiful and functioning at the same time.
That'll be a joy to see when you've got that ready.
I agree. Yeah.
Well, Isaiah, thank you so much for
You're welcome.
walking us through this. It absolutely tremendous. I mean, it's stunning. Again, just the scale is impressive, and the quality of workmanship is just amazing.
Thank you so much, and thank you for coming and doing this interview.
Oh, absolutely.